The year is 1884. On a New York City rooftop, something extraordinary is happening. Charles Fritz, an American inventor, installs the world's first photovoltaic solar panel. It's a far cry from the sleek panels we see today. This pioneering device is massive, about the size of a billiard table. It uses selenium and gold to capture sunlight and convert it into electricity. The efficiency is less than 1%, but it is a start. The seeds of a silent revolution have been sown. Fritz's invention goes largely unnoticed. The world is in the grip of the Industrial Revolution. Coal and oil are abundant and cheap. The idea of harnessing the power of the sun seems like a distant dream. But Fritz's work lays the foundation for future generations of scientists and engineers. They will continue to refine and improve solar technology. Fritz's story is a reminder that great inventions are often born in obscurity. It takes time for their true impact to be felt. The solar panel revolution may have had a quiet beginning, but its future is anything but silent. The stage is set for a new era of clean and sustainable energy. The early 20th century sees the emergence of another solar pioneer. In 1909, George Cove, a Canadian inventor, unveils his solar electric generator. Cove is a charismatic showman. He demonstrates his invention in Halifax, Nova Scotia, claiming it can power a home for 10 years for a mere $20, about $660 in today's money. The public is captivated. Cove's invention captures the imagination of a world hungry for new sources of energy. Cove's company raises an impressive $5 million in funding. It seems like solar power is on the cusp of a breakthrough. But fate has other plans. Cove's venture is plagued by misfortune. A kidnapping incident rocks the company. Meanwhile, the rise of cheap and abundant coal and oil deals a fatal blow to Cove's solar dreams. His company collapses. Cove's story is a cautionary tale of ambition and misfortune. It highlights the challenges of introducing disruptive technologies in a world resistant to change. Despite its promise, solar power is still decades away from becoming a viable alternative to fossil fuels. The world will have to wait for its moment in the sun. In 1918, a serendipitous discovery in a Polish laboratory will have a profound impact on the future of solar energy. Jan Czochralski, a Polish chemist, accidentally discovers a method for growing single crystals. Czochralski's method revolutionizes the production of high-purity silicon. This element will become the cornerstone of modern electronics and solar panels. At the time of Czochralski's discovery, its significance to solar energy is far from obvious. The world is preoccupied with 2 world wars and the rise of industrialization. But in the decades to come, Czochralski's method will pave the way for the mass production of affordable and efficient solar cells. Czochralski's story reminds us that scientific breakthroughs often have unintended consequences. Sometimes the most significant discoveries are the result of chance and serendipity. His work lays the groundwork for a technological revolution that will transform the way we generate and consume energy. The middle of the 20th century marks a turning point in the history of solar energy. In 1954, a team of scientists at Bell Labs, the birthplace of the transistor, develops the first practical silicon solar cell. This breakthrough achievement will have far-reaching consequences. It paves the way for the development of solar panels that are efficient enough to power everyday devices. The Bell Labs solar cell achieves an efficiency of 6%, a significant improvement over earlier attempts. This breakthrough captures the attention of the world. It sparks a surge in research and development in solar technology. The stage is set for solar energy to emerge from the shadows of obscurity. The success of the Bell Labs team demonstrates the power of scientific collaboration and innovation. It also highlights the critical role that private companies like Bell Labs can play in developing and commercializing new technologies. The future of solar energy is beginning to look bright. Section 5. From Earth to orbit, solar power takes flight. In 1958, solar power takes a giant leap forward. Literally. The Vanguard 1 satellite, launched by the United States, becomes the first solar-powered object in space. This milestone event captures the world's imagination. It demonstrates the potential of solar energy to power devices beyond the confines of Earth. Vanguard 1 is a technological marvel for its time. It is powered by a small array of solar cells that provide a continuous supply of electricity. The satellite orbits Earth for several years, transmitting valuable data back to scientists on the ground. Its success paves the way for the use of solar power in future space missions. Vanguard 1's journey into space marks the beginning of a long and fruitful relationship between solar energy and space exploration. It also highlights the versatility and reliability of solar power in extreme environments. The sky is no longer the limit for solar energy. Throughout the 1960s and 1980s, solar panels start to find their niche in a world still heavily reliant on fossil fuels. They prove to be ideal for powering remote locations where access to the electricity grid is limited or non-existent. Applications include powering radio towers, weather stations, and bringing much-needed electricity to developing countries. In these remote settings, solar panels demonstrate their unique advantages. They are relatively easy to install and maintain, require no fuel, and produce no emissions. Solar energy provides a lifeline to communities that would otherwise be left in the dark. It also offers a cleaner and more sustainable alternative to diesel generators, which are often noisy, polluting, and expensive to operate. The adoption of solar panels in remote areas highlights the social and environmental benefits of this technology. It demonstrates that solar energy can empower communities, improve lives, and reduce our reliance on fossil fuels. The seeds of a global energy transformation are being sown. In 1989, a significant breakthrough in solar cell technology ushers in a new era of efficiency. Scientists develop multi-junction solar cells which are capable of converting a greater portion of sunlight into electricity. This innovation has a profound impact on the solar industry, paving the way for more powerful and compact solar panels. Traditional solar cells are limited in their ability to capture the full spectrum of sunlight. Multi-junction cells overcome this limitation by using multiple layers of semiconductor materials, each tuned to absorb different wavelengths of light. This innovative approach significantly increases the overall efficiency of the solar cell. The development of multi-junction solar cells is a testament to the ingenuity and perseverance of scientists and engineers. It demonstrates that continuous innovation is key to unlocking the full potential of solar energy. The efficiency of multi-junction cells continues to improve, further solidifying their position as a leading technology in the solar industry. As the 21st century unfolds, the solar industry is abuzz with excitement over new and emerging technologies. Bifacial solar panels, capable of capturing sunlight on both sides, are gaining popularity for their ability to generate even more electricity from the same footprint. Meanwhile, perovskite solar cells, a new class of materials, are making waves in research labs for their potential to achieve even higher efficiencies than silicon-based cells. Bifacial solar panels are particularly well suited for installations where sunlight can be reflected onto the back of the panel, such as in ground-mounted systems or on rooftops with reflective surfaces. Perovskite solar cells, while still in the early stages of development, hold immense promise for their potential to revolutionize the solar industry. These materials are cheap to produce, highly efficient, and can be printed onto flexible substrates, opening up a world of possibilities for solar applications. The emergence of bifacial panels and perovskite solar cells highlights the rapid pace of innovation in the solar industry as scientists and engineers continue to push the boundaries of what's possible. We can expect to see even more efficient, affordable, and versatile solar technologies in the years to come. No discussion about the solar revolution would be complete without mentioning the crucial role of energy storage. While solar panels excel at generating electricity during daylight hours, the intermittent nature of solar power has long been a challenge. However, advances in battery technology, particularly lithium-ion batteries and newer alternatives, are changing the game. Batteries allow homeowners and businesses to store excess solar energy generated during the day for use at night or during periods of low sunlight. This capability greatly enhances the reliability and value of solar energy, reducing dependence on the grid and enabling a true transition to a clean energy future. As battery technology continues to improve and costs decline, we can expect to see even greater adoption of solar plus storage systems. This powerful partnership is transforming the way we generate, store and consume energy, paving the way for a more sustainable and resilient energy future.